Hello everyone, today's video is about the introduction of sets, and I'm going to give you definitions for sets, subsets, universal sets, null set, and cardinality of sets. And of course, I will give examples. Alright, so let's begin. How do we define a set? Well, basically a set is a well-defined group of objects. Okay? Now, each object in a set is called element. Now, those elements in a set, they share a common characteristic. For example, factors of 8, 1, 2, 4, and 8. 1, 2, 4, and 8 are called elements. So each of those 4 is called element. Now, there is a common characteristic among those 4. And why is that? Those 4 are factors of 8. Let me give you another example. Okay, so here we have sports that Dustin loves to play. We have chess, basketball, and football. Like what I said, each of those 3 sports, we call them element. As a group, they are elements. And then the common characteristic of those 3 sports is that they all loved by Dustin. And last example here, classes of Anna this semester. These are Constitution, College Algebra, and Chemistry. And again, there is common characteristic among those 3 elements, and that is these 3 are classes of Anna this semester. Alright, let's go to the next definition, and that's subset. So the set F is a subset of set A if all elements of F are also elements of A. Okay, let me give you an example. So here we have factors of 12. So that is set A. We have 1, 2, 3, 4, 6, and 12. Now we have a set F here. And the elements are 2, 3, 6, and 12. Now 2 is here for set A. 3 is here in set A. 6 is also here in 12. So that means F is a subset of A, and this is the notation of that. We can actually have more than one subset. So say for example, let's have set B, and then the element of that is, let's say, 1 only. Okay, now that 1 is, or set B rather, is also a subset of A, because that 1 is an element also of set A. One last example. For example, we have set D, and the elements of set D are 3 and 6, for example. Now 3 and 6, which are the elements of set D, are also elements of set A. So we can say that D is a subset of A. Alright? Now, there are 2 different kinds of subset, and the first one is what we call a proper subset. So how do we define that? Okay, so here it says that set D is a proper subset of set B if set D does not contain all elements of set B. Okay, I think that is clear, and I gave you examples for this one earlier in the previous slide, but let me give you this example. So let's say set B, even numbers from 1 to 10, and they are 2, 4, 6, 8, and 10. And then there's another set, which is set D, and the elements of set D are 4 and 10. Now, elements of set D are only 2, and the elements of set B are 5. So, and those 4 and 10 also are in set B, but it's not all the elements of set B, which means that we can classify that D is a proper subset of B. So that this notation right here is actually means proper subset. Right? Of course, if there's a proper subset, there is also what we call an improper subset. So what is an improper subset? Set T is an improper subset of set R if set T contains all elements of set R. So for example, odd numbers from 1 to 10, 1, 3, 5, 7, and 9. And then there's another set, which is set T. And then incidentally, the elements of set T are also the elements of set R. So which means that, we can say that R is, but this is not right here. Hi everyone, today's video is about the introduction of sets, and for today I'm going to give you the definitions of sets, subsets, universal sets, null set, and cardinality of sets. And of course, on top of that, I will give you examples, alright? So let's begin. How do we define set? Well, set is a well-defined group of objects, okay? So in a set, there are objects, and those objects are actually called elements. And the elements in that particular set, or in a particular set rather, they share a common characteristic. So for example, oh no. Hello everyone, today's video is about the introduction of sets, and for today I'm going to give you the definition of sets, subsets, universal sets, null set, and cardinality of sets. And of course I will give examples for us to be able to understand better the definition of these terms. So let's go to the first term, which is set. How do we define a set? So a set is a well-defined group of objects. Now, the objects in a set are called elements, okay? And the elements, they share a common characteristic. For example, here, factors of 8. 1, 2, 4, and 8, those are the objects, and they are called elements. We have 4 elements here. And these 4 elements, they share a common characteristic. And what is that? They are all factors of 8. Alright? Let me give you another example. So here, example number 2, we have the sports that Dustin loves to play. We have 3 elements here: chess, basketball, and football. And again, these 3 sports have a common characteristic. And what is that? These are the sports that Dustin loves to play. Okay, finally here we have classes of Anna this semester. And again, there are 3 elements here: constitution, college algebra, and chemistry. And these 3, They have a common characteristic, and what is that? They are all classes of ANA this semester. All right. Now, in a set, there is what we call a subset. So how do we define a subset? The set F here, no, we don't have that. I will give you an example for that, of course. So imagine there's a set F. We consider that as a subset of set A if all elements of set F are also elements of set A. So for example, set A factors of 12, we have 1, 2, 3, 4, 6, and 12. All right, now in set F, the elements are 2, 3, 6, and 12. But if you look at all the elements in set F, look at that, 2. That's also in set A. 3. That's also in set A. 6. That is also in A. 12. That is also in A. So we will consider set F as a subset of set A. And this is the notation of that. So that means F is a subset of A. All right. Now, there are two different types of subset. And the first one is what we call a proper subset. Okay, so how do we define a proper subset? Set D is a proper subset of set B if set D does not contain all the elements of set B. Okay, so for example, okay, so here, even numbers from 1 to 10, 2, 4, 6, 8, 10, and then we have a set B and it has two elements only, 4 and 10. And again, 4 is also in set B, 10 is also in set B. So this notation is actually means proper subset. And we can actually have a lot of proper subsets here. So we can, let's say we have another set, and let's name that as set E. And for example, the element of that is only, let's say 6. So set E, all right, is also a proper subset of B. Last example. So let's say set F, and it has an element of, let's say 2, 8, and 10. All right. And again, these are not all the elements of set B, but they are also elements of set B. So we can consider F as a proper subset of set B. All right. And of course, the opposite of proper subset is what we call improper subset. And here, we can consider a set. So say, for example, set T is an improper subset of set R if set T contains all the elements of set R. For example, set R. We have all the odd numbers from 1 to 10. 1, 3, 5, 7, and 9. And then we have set T. And the elements of set T incidentally are also 1, 3, 5, 7, and 9. So that means we can consider set T as an improper, that's a symbol for improper subset of set R. And vice versa, we can actually also say that R is an improper subset of T. Okay? Now, what else do we have here? Empty set. So an empty set is also called a null set or a void set. It is a set that has no elements. So an empty set is denoted by these two symbols, but normally we use this one. For example, okay, so here, set of all integers divisible by 9 from 1 to 5. 1, 2, 3, 4, 5. Is there an integer there that is divisible by 5? There's none. So that's an empty set or a null set. Alright, so here we have a universal set. How do you define this one? A universal set is a collection of all elements or members of all the related sets known as its subsets. For example, okay, so here we have a subset A. We can consider that also a set A And let's say that's all the vowels, A, E, I, O, U. And let's say we have a subset B. Again, we can also call that a set B, and that is all the consonants. Now, we will consider, let's say there's another set, and actually there's another set here, which is set C, which is composed of all the vowels and all the consonants, and that's basically all the letters in the English alphabet, and we call that a universal set. All right? And of course, the last term that I am going to discuss here is the cardinality of a set, and is defined as the number of elements in a mathematical set. For example, set A, we have 1, 3, 5, 7, and 8. And how many elements do we have? 5. So the cardinality of set A is 5, or we can put a notation like this, and the answer is 5. So there you go. These are the important terms that we need to understand as we move forward to our lesson about sets. Okay, so thank you for watching. I hope you learned something, and please don't forget to subscribe to my YouTube channel. Thank you and have a nice day.